All right, and then we're moving to this, swiftly moving to the second speaker of the session, which is Artur Podhorodecki from QNA, who I believe will be, Artur, maybe you want to hand out? Okay, I'll introduce you and I'll use the microphone. So educate us about all the possible color converters in using quantum dots. Be prepared about the efficiency in the red. I think many will ask.
Thank you, Olga, for a nice introduction. My name is Artur. I'm the CEO and co-founder of QNA Technology. So we are a company, quite young company, especially for this kind of society. So I will, at the beginning, try to introduce your company and tell you a little bit more about our products. And then especially I will focus on our materials, which we try to introduce to micro display, but also give you a few slides, show you a few slides about our materials which could be used for electroluminescent displays, which is another type of fascinating technology. So we are a company located in Poland. We are still a startup type company. We are 24 people. Most of us are R&D people, so pretty simple organization structure. We are located in Technological Park in Poland, in Wrocław, which is close to the Dresden. We do in a company several activities. First of all, we develop technology itself. So we spend some time on scaling our synthesis, purification processes, development, solvent reuse to reduce cost of our materials. So this is a part of activity which we also try to develop. But our main focus is on material development, and we also do a lot of surface modification of our materials. And for those who like to print quantum dots, we also try to develop quantum dots-based inks. Quantum dots, small crystals of semiconductor, I think I don't have to spend much time on that. The fascinating thing about them is that they combine semiconductor quality with all this functionality of organic materials, so you can print them. So you can print semiconductors on foil, on paper, on glass, without many limits present in other technologies. Our company is focusing on blue light-emitting quantum dots and heavy metal-free blue light-emitting quantum dots. Our whole team is focusing mainly on this one purpose since 4 years from now. And the blue meaning from around 420 nanometers up to 460 nanometers. At the same time, when we are developing technology, the materials, we are also developing technology, as I told you at the beginning. So we, for now, can already deliver quite substantial quantity of these materials. We just built this year our first experimental pilot line, and this line should be ready and have a full capacity at the beginning of next year. So with our materials, you can go through all the processes from testing, pilot production, and also in the future, we would like to go for the mass production. So we try to assist our partners for the whole process. We are present mainly in Asia, in Japan, in China, so you can buy our materials from that places on the world. Trying really hard to build some network in Europe, but it's challenging for many reasons. And that's it about the company. So what we offer right now, we in fact have two kinds of quantum dots. The ones we call the deep blue, which are probably not so much interesting for you, which emitting from between 420 and 445 nanometers. But for display application, we are focusing on PureBlue.dots, emitting from 445 to up to 460. And these materials we can deliver in different forms, different solvents, monomers, and also we can customize for them if you have really some special needs. Our materials have already nice quality, 80% and over 80% PL quantum yield for quantum dots in solvent and quantum dots in the monomers. From the color point of view, they are really very high quality already, and the purity is also nice, and as I mentioned, the scale could be also substantial already. We also working on inks, and our first products we work on are UV curable inks. And we work on high concentrated inks with a high quantity of quantum dots. And at the same time, we were trying to develop inks with the low viscosity, just to make inks with the high content of quantum dots printable with the inkjet technology, for example. Just to give you a feeling what we do also, we right now working on photoresist. It's early stage. We already have a quite nice positive results. So if you're really interested about these materials, we would be happy to learn more what specific parameters you would like to have for this